understand your journey, your journey as an entrepreneur, your background perhaps, and then why did you end up being into this AI space?
Yeah, so when I started, I was pretty far away from actually being an entrepreneur. So I was, since my childhood, just heavily interested in science in a very general, broad sense. So I always wanted to understand how things work out. How does this work? Yeah. And so that quickly got me into science. And due to the time, so I grew up basically my adolescence in the second half of the 70s and the beginning of the 80s. And then that was a quite pioneer time for computing and programming, and it was not yet so much computer science, but it was like computer kids, how that was called at the time. Yeah, so and I was one of them. And what fascinated me with computers was not even the computer itself, but it was the idea that a computer is a tool that allows you to model anything. Yeah, you can, whenever you have a system out there, you can find a way of abstracting it and putting it in your computer, and that would allow you to either speed up time, so you could sort of time lapse some idea, some model, and see how would that work out after 10 years or 20 years or whatever. Or you could suddenly handle quantities that you could never handle in real life. So basically the idea to model stuff that's interesting or relevant and to be able to amplify it wherever your interests go without having the limitation of the physical world. Yeah. So stuff, what is the most frequent word in the German traditional mythology, for example? Yeah, stuff like that. Yeah, so that was the kind of interest I had at the time. It was very close to topics like electronics and so, which today doesn't seem to be anymore. So you can be a computer scientist without ever having a soldering iron in your hand. At the time, knowing how to program a computer would mean also know how to solder and things like that. I then decided when I had to decide what kind of education I would follow. I was, of course, interested generically in natural science a lot, but also, as I said, in computer science. And then I decided, no, I will actually do my formal studies in natural science. At the time, the most general natural science education was medicine, funny enough, a bit different than it is today. So I decided to study medicine, which I did in Vienna. And I basically started my professional life as a programmer, doing computer software for completely sort of only business terms. So this was not yet related to my actual content. And I started to get more and more interest in the research part of medicine. And that was the moment where knowing how to set up a database was an advantage, so to say. So people wanted you in their teams and things like that, because you could help them to collect the data properly and stuff like that. And I did this until the year 2000, interestingly. And ended up working in a specific area, which is transplantation medicine. And I did a lot of data management and research, analyzing sort of genetic information. And so, but all of that in a very early stage, which means that you had to craft everything yourself. So that was basically the bonus for me. Is I did not just learn how to formulate a SQL statement, but I had also to learn how to set up your data systems, how to install a SQL server on a physical server and stuff like that. And that sort of allowed me to get quite some hands-on practical experience. As I said, I did a lot of research work then, because I was in kind of a pool position of being someone who understands medical language as well as computer language. And in the year 2000, basically, I had sort of the feeling that I needed to change something in my life. And although everybody in my family and my private environment, they always said, yeah, Francisco is not the businessman. He's kind of the crazy professor, rather, yeah. So I had this view of myself that I'm completely sort of unexperienced and unable to sort of see the world from the perspective of an entrepreneur. And I just started. I left the academic environment and started my first company that was mainly around the concept. So that's the other thing. Like in research, you need a topic, a personal topic that you pursue along your career. And I sort of instinctively did the same approach to my business activities. So I was not kind of the person looking for an opportunity and then trying to fill that opportunity, or discovering a certain need for something or a product. But my approach was more, I want to do business while I have sort of a mission that I want to bring to people. Yeah, and so the early 2000s, you know, were very much about the internet and the bubble and everything. So that was shortly before the bubble, actually, when I started. So my mission then was to get business people interested in open source software. Because at the time you had these monopolists, you know, Microsoft, Oracle, Sun, and so on, who provided all the so-called business systems. But I was sort of nerd enough to know about the early Linux, about open source development platforms, stuff like that. And the goal of my first company was to challenge sort of traditional, I would say, database-driven e-commerce sites in a wider sense. That those were early days, so e-commerce was a pretty broad concept. But it turned out that in order to sell something, you need some kind of database, and you need a web access to that database, and that would be sort of the backbone of your business. Yeah, and people just spent enormous amounts of money licensing, even for tiny little projects, enterprise class Oracle servers and stuff like that. You know, people were just inexperienced at the time.
Yeah.
And so my approach was to participate in RFIs and similar by saying, with our company, only pay our work, but you basically don't need to pay a license fee for being able to use a database. So we had open source databases that we worked with, and in the end, we typically were at, I don't know, 20% or lower than the regular commercial offers. And we did a number of, for the time, again, quite large e-commerce sites and so on, that basically gave me the first kind of experience in how to operate that sphere. I mean, the specific challenge was then, and to some degree is still, that you have to sell something that the buyer doesn't understand. Yeah, so this is a fundamental issue. Yeah, so at the time, people had no idea what was behind an e-commerce site. There were like 3 e-commerce sites available. Yeah, and don't forget, all of that happened in Austria, which is yet another. Yeah, I mean, I'm not talking about California or whatever.
Exactly.
That was Austria. Yeah. So that was the challenge, and there was basically when I found out that my fundamental skill of wanting to understand stuff also enabled me to sort of explain stuff, because only when you understand something you can really explain it.
Yes.
And that was basically my sort of approach. I had of course, there was a big influence from scientific thinking. Yeah, so I can give you an example for the positive aspect and the negative aspect, and you have to figure out. So I did not I did not have this sort of generic marketing approach. Yeah, trying to put everything in pink pastel colors in front of the customer, but rather sort of having a real sort of discussion and figuring out, according to your answers, that seems to be the optimal solution. And so it turned out that business people liked that and connected with this, because they always had the impression, okay, I do understand at least what's relevant for me. And the other thing is that I tried to sort of communicate that there is this, so it's not just having a piece of software that has a certain function, but you have to also consider who are the people using that software within your company and how will they use it. So getting them to understand that even if the product is software, the use case is not just software. It's actually people working with software, and that is what has to be more efficient than the way you did it before. Yeah, so that was at the time in Austria quite a sort of good offering, especially as the budgets were sort of orders of magnitude smaller than in California. Not only by not in the sense that there wasn't enough money, but the market, the Austrian market, is simply smaller, and there is this, I would say, European digitization latency that's somehow part of the system. So there was also the convincing why should you sort of step forward in digitizing your business. And I remember I had still in the early 2000s conversations with CEOs here where they said, yeah, but I just invested in my fax infrastructure, and now you're telling me that we need email. What exactly is the advantage of email? So that's the kind of argumentation I had to do. Yeah, so, but that was very early, and that basically first company allowed me to get the practical experience in how you get a team of people to solve technically a problem that a customer has. So there is also this kind of, how do you structure such a process? How do you manage them? And I just came out of the blue, yeah. So I had to teach this myself by experience. But I think I was lucky in the sense that times were of the kind that people also accepted this. So that was just a socially innovative time, I would say. And so we went quite successful. We then merged that first company with another IT company, and then started also larger, more international projects. By that, I got involved for the first time in what at the time was called search technology, which then became information retrieval, which is today called AI, like most of the things. That search engine thing was interesting to me because it was a very interesting mixture of science and technology. So you have to have a certain, in principle, or scientific understanding of how search works, especially if you do statistical modeling and those kind of things. There has to be a certain understanding. And the other thing is that people started to have quite big repositories of data, and they were wondering why they don't find anything anymore, because people told them, yeah, you have to type this in your computer so that you have it at your fingertips. Yep. And then when it came to the moment to actually have it on your fingertips, they found out it's quite hard. And so search became a bigger and bigger sort of topic. At the time, we were part of a number of then early projects, which today ended up in large corporations like Thomson Reuters, where I recently found out that one of my early software childs sort of ended up being a product at Thomson Reuters and things like that. It was also interesting because you had the first big search companies like Autonomy, for example, who came and have shown a whole new kind of doing business with search, which was not clear before. In that configuration, we one day had a project with a customer who was actually the European Patent Office. And that changed everything again, because I realized that that's probably the most complex kind of search you could find. I mean, documents, literally, you can read a patent document over 50 pages and don't even figure out what they talk about. Yeah. So it's really complicated, even for a human. Yeah. So you have like technical stuff that's described there. You have business stuff in the claims. You have legal aspects, and I realized the big professionals in the very large companies, they work with stuff that's at least 30 years old. Yeah, they were sitting in front of these black screens with green characters, typing in pages of queries, just because that was so important and also valuable, of course. I mean, there's a lot of money involved in patenting. And the other thing was that it brought an access to the enterprises. Yeah? So at the time, I had very little experience with super large companies. And so we decided, let's specialize and let's start a company that tries to improve that whole patent data processing. And again, we wanted to do stuff that hasn't been done before. So that turned out to be a bit a topic of my business work. What I hated most is to have competition, to be honest. So choosing a commercial opportunity was, for me, looking where is a lot of need with the least possible competition, which typically points to areas that are more complicated. Yeah, so if there are not a lot of people trying to solve this, but people are needing it, then it's because it must be quite complicated. Which was the case, actually, with the technical possibilities of the early 2000 years, so 2005, 2006. It mattered how big your search index was, yeah, much more than it does today. yeah, and so we started to go in this direction, and we quickly found out that it was impossible as a startup, which we were, like, I know in the beginning we were maybe 10 people when we started, but it was impossible to get all these different expertise to actually help those enterprises like, I don't know, Henkel, BASF, the big guys who do a couple of thousand patents a year. And so, my decision was then, okay, if it's too hard to build the capabilities, we have to find a mechanism that provides us with the capabilities. And so I decided to start in parallel to the company a research institute in order to get in contact with the researchers, in the optimal case internationally, to find the group who has done most work in analyzing chemical patterns, for example, what was needed from the patent guys. And then I said, okay, what can I do to get in contact with academic institutions? And I said, okay, what they are struggling with is that they need to do large-scale experimentation with text data. But typically they don't get the resources they need in the universities. At the time, computing was extremely expensive. And if a university invested in some, unquote, supercomputer, then it was given to the physicists and the groups within the academic circle who had a bigger impact than this tiny little natural language processing and search group. They were more exotic at the time. And so I said, okay, what I will do is I will fund as a company a large supercomputer. I will put on this supercomputer one of the largest text collections, namely the global patent collection. And I will allow researchers to run their experimentation there for free. And in order to sort of make a decision who's allowed and who's not, I will invite a bunch of senior researchers to become sort of a scientific board, and then research groups can apply for computational time, and that scientific board will then decide if and how much access they will get. And interestingly, that mechanism worked extremely well. And within 2 years, we were like 120 people on the company side. And we were another 20 people working on this scientific sort of institute side. And we had a couple of hundred researchers doing their experiments there, which again attracted the big industries, because they saw, okay, there is a lot of sort of intelligence there. Let's go there and try to solve our problems together with them. And that worked pretty well. So suddenly, although we were in Austria, we became quite international. We had teams and researchers from California to Tokyo who were part of that system. That was basically the time when I basically have grown my own knowledge on the topic. So much of it again was self-thought and sort of interactively done. And then, unfortunately, 2008 came, which made life hard for startups at the time. Yes. We were in the middle of sort of getting our breakthrough. So yeah, things had to stop at some point. And we basically, we had a partner in the US at the time who basically took over the commercial activities, but we had to to stop the institute part. It was a problem because at the time it was very hard to get public funding for these kind of topics. That was sort of completely, what exactly are you doing?
Yeah, yeah.
So
nobody would be interested. Yeah.
Yeah, natural language processing. That was I don't know. Yeah, so that's old Roman painting could have been some a similar topic. Yeah, but my biggest learning then was actually that by applying the state of the art, literally from the leading research people in the field, I still had the impression we actually never reach anything close to a human level capability. So the best thing we could do is to sort of amplify the power by which you can approach certain data. But I literally could feel that my 4-year-old has definitely more intellectual capacity than any of our systems. And that was basically the moment, so around 2010 or so, especially as we have sold off the company. I had free time again to some degree. I was sure that I wouldn't want to return to academic work, so I started to get the taste of entrepreneurship. So basically, the decision was, okay, let's see what we can do now. And I started to do sort of theoretical research on a more fundamental shift. Yeah, so that's maybe also has to do with my avoidance of competition. I don't want it to do or try stuff that 5,000 other people are trying right now. I would want to find my own way of solving things. And then that was the moment when I came across a book from Jeff Hawkins. So he's quite known in the entrepreneurial world as being the founder of Palm, which was a categoric new kind of handheld computer. But fundamentally, he was a passionate neuroscientist. And once he sort of left the entrepreneur world, he became sort of a private researcher, if you want. And his work was just fascinating to me because he wanted to find out what is the principle behind the way we, the neocortex, so the part of the brain which thinks, works. And that was just fascinating to me, and my sort of medical background gave me also a sort of quite fundamental way of connecting with that approach. And my big question was, how could computers find out what a word means? Yeah, that was at heart, that was my question. And by just having this sort of naive approach of saying, okay, but the only reference implementation for processing natural language is actually the brain. That's the only machine we know that does this adequately. And so that became sort of my the field where I tried to get deeper and deeper to find a solution. And in fact, I ended up one day sort of having the light bulb go up. Exactly. And I think this was just due to the amount of energy and information I tried to bring in, and at some point it just was clear in front of me. That was in 2011, roughly. And then I took advantage of the fact of being in Austria, and we have a pretty sound applied science funding scheme here in Austria. I wrote up, I don't know, 80-page description of what the concept was, and I applied for money to build a prototype to see if that actually works in reality. And I got that money and was able to make a first implementation of it, and it turned out it worked even better than I would have anticipated. Yeah, and from there, basically, we started like a traditional startup. So we went with the prototype, showed it to business people, encountered a business angel who got interested, who invested the first amount that allowed us to hire the first team of engineers to actually create a first product version of it. The interesting thing was, though, that it was still a very experimental approach. So it was not easy to say how the next year will develop, because we were not clear what else will we find out by this approach within this year. Yeah? So there had to be certain kind of flexibility. On the other hand, there was this impact of artificial intelligence on the other side of a market that, to me, already showed early signs of hysteria. And I came out of the 2000s where I experienced my first hysteria. So I thought, oh, what? Very, very similar symptoms. But unfortunately, the general market decided to go the way of brute force in terms of AI. So it was not finding some generic AI approach, but rather just making use of the cheap computing power available at the time, and just do the stuff we did 10 years ago, but just with much more power. Yeah, and it turned out that this was able at least to produce certain interesting demos or effects. Yeah, so it became interesting for people that suddenly you could do certain things that were that people thought were very hard to do before. Yeah, so detecting a cat on a picture. Yeah. So people have tried this since the 70s, and suddenly you had a guy who demonstrated to you a piece of software that actually does it. Yeah. And that was completely incredible. Which in the end led to OCR that actually worked. Yeah, I mean, I was living 10 years before with OCR that was just crap. Yeah, you had the beginning of things like machine translation. Yeah, I have worked in the context of patents with machine translation, and it was crap at the time. Yeah, and suddenly all these things who were basically unthinkable for technology people became thinkable. Yeah. And at the same time, I realized that the approach we had was very different from what all these successful people are doing. Yeah, so that was sort of a strange situation. Nevertheless, we were able to keep up in terms of capabilities with the mainstream, although doing things very differently from the mainstream. Then there came this next phase that was in like 2016 or so, where the limits of the brute force AI started to show up. Yeah, so you had systems that in principle could solve that very well, but unfortunately in that use case there is not enough training data available, so they can't get the models to work properly. And suddenly we were confronted with failed projects in the industry. So very often we came to customers and they said, yeah, we have just failed with a project using IBM Watson or some other of the big commercial players. And we could demonstrate that with our approach, we could actually help them. And it became clear to me that, in fact, that race that happened in terms whose system has a higher precision. Yeah, you know, there were these benchmarks and what level of precision can you achieve with this algorithm or with that algorithm. And people basically competed by throwing in more and more resources, basically, to do these models. And that was the moment when I realized that, in fact, our advantage and success with these kinds of projects was not our precision levels, but it was the efficiency. And that's what I found out to be the key for all AI problems, because having an algorithm that has 99% precision, but it takes you 3 billion computing hours to build the model, then that's as if you have no solution to your problem, because you will never figure it out. On the other hand, if you only, I don't know, need a half an hour computation of your model, then you can, in a week, refine that model very often, because you can compute it and tune it very often, and you achieve the goal of a certain precision by just having more possibility to optimize it. And so that's basically, as of today, our main ROI sort of indicators have to do with the efficiency. So when a traditional algorithm needs 10,000 hand annotated examples to train a model, we need 100. That's the goal. We try to stay in the realm of data that's actually manageable by people. Nobody can handle 100,000 example records. You need a system to do this. But 100 examples, 2 or 3 subject matter experts can manage to come up together with 100 examples. And so that basically turned out to be our goal. And in the end, I have to say, the biggest reason for struggle that we have is that we are just quite different from the mainstream sort of company. And that is sort of our challenge. Being an Austrian company that tries to sell on a global market to large enterprises while using a proprietary technology where basically no famous research institute stands behind it. That turns out to be the biggest challenge, not actually solving the problems when we get the opportunity.
Interesting. The thing is, you had quite a ride, right? So you had that. I would say, I have had those experience of living in an era where there was no internet. I believe, like yourself, to an era where my son knows perhaps everything now. Those times, right? So like you said, your 4-year-old has more ability than a let's say AI enabled devices perhaps. And then I was a little bit curious about the prospect of AI, right? So we're talking about AI left and right. And I'm kind of curious, like, okay, what are the things perhaps a human brain can do, and that can be mimicked by using AI? What are the things there are limitations? What do you think the limitations are, perhaps? And what can be trained? What have you learned? Because you are from the, let's say, biological space as well, and also on the computer space as well. So when you have to now say, these are some of the limitations the AI will definitely have, or maybe in future we will not have those limitations.
Yeah, so I would say compared to the human brain, and I consider the human brain also to be some kind of information processing unit. So I don't believe that there is any magic or so happening. So I think everything the human brain is able to do is actually computable to some degree. It might be super complex, but it is computable, definitely. Obviously, even with things like 10 watts of energy, this is computable in real time. But I think that the problem, the second thing I think is that there is like one algorithm there for doing these computations. And it's not by finding, and the third thing is that obviously the brain creates models of the world. Yeah. So these are all things which are super compatible with our understanding of what AI does. The only difference is that the brain has evolved. It was not designed. And evolution guides you along efficiency, yeah, mostly. And that is what we are lacking in our approach of AI. Yeah? So we are trying to solve problems by brute force, by throwing more processors, more data, more everything there. So you probably heard the most famous language model that was built recently, the GPT-3, uses, I don't know, something like 150 billion variables or something like that, which is by far more than you would fit into a human brain. But it still sort of generates language that reminds me a neurotic autist kind of output. Yeah. I mean, it's astonishing what effects you can produce. Yeah, it knows words in other languages. It sort of by default seems to understand what you are asking, and so. But what is not said that behavior is not very reliable. Yeah, so. It might work out nicely in some situations, in others it doesn't. For the engineers to get something like GPT-3 to the degree that it does reliably what you expect from it, I don't see that anytime soon, that we really get this under control, because just the scale of the involved operations, yeah, you add one multiplication in your whole formula, and the model computation takes a half a year longer. Yeah, so that's the kind of problems you face here. And fundamentally, it shows me that's obviously not the way how the brain does it. And so I think the big difference is that the brain is not working with statistics and floating point numbers. It's working with set theory and geometry. Yeah? So there is a real sort of difference of kinds that is there. The problem is that there is, of course, always commercial pressure. There are many industries who see an advantage if more power is needed, and so on, for selling more computers or selling more storage and selling more everything. So it's a bit of a self-feeding ecosystem that's not easy to sort of change. Yeah. Yeah, so that's how I see the AI aspect today. So a principle, I think that everything the brain does can be sort of built once we have at least roughly understood what kind of architecture the brain uses to do this. But the problem is, if you go deeper and deeper, and that's what I've been doing over the last years, you realize that you have to change also the fundamentals. So all of our computers work with an architecture that comes from von Neumann. So it's called a von Neumann machine. So you have a processor, you have a memory, and you have an input-output system, and then the data bounces forth and back from this. But that architecture has a fundamental limitation, namely the speed by which you can move the data. So to me, the answer is even more fundamental than just that's the way how I started is basically to say I don't concentrate on the algorithm, I concentrate on the representation of the data. The representation seems to be the problem. And what I found out is if you get the proper representation, suddenly the algorithm becomes super simple. Yeah. So the way how we represent text data basically in our semantic folding approach is by using fingerprints, we call them, which are little bitmaps with patterns on it that stand for the meaning of a word or a sentence or and so on. And once you have found a way to properly convert text in such a bitmap pattern in a way that two similar words generate two similar bitmap patterns, then the algorithm becomes simple, because then you put one pattern on top of the other and you measure how much overlap you have between the two. And that seems to be exactly the way how the brain works. It generates large patterns of activation, and then it compares that activation with some historic activation or some other pattern. And that's how we think, is by basically comparing patterns all the time. Yeah. But the other thing is that when you sort of continue that path, you find out that actually the brain is not a processor. The brain is actually a memory system. It's a memory system that's able to do some kind of primitive operations on their memory cells. And the speed comes in from the fact that all the memory cells can do their processing at the same time. So you don't have the problem of the von Neumann machine where you had to read a memory cell, bring it to the processor, process it, store it back, take the next memory cell. But here you have all your memory cells and you tell them, compare yourself to that pattern. And all your memory cells in the same moment compare themselves to that pattern. And the interesting thing is, on a purely conceptual level, independently of how many memory cells you have, the comparison operation remains always the same, because it's always the time that one cell needs to do the comparison. But as all the cells are doing it simultaneously, you can increase the volume without delaying the result. And that's completely sort of contrary to what we know from computers today. Yeah, and accordingly, I had to go in the direction of also considering developing new kinds of computers who actually process that data that we found out how to represent data. And yeah, so we had also on the commercial side to find a partner and started developing new kinds of processors, sort of, that would be built in a way that would be the generic way how that kind of processor processes data, which is very different from the von Neumann. Yeah, so that's in fact where we are today. And as you can see, I'm as an entrepreneur, it seems as if I'm systematically fleeing crowded places and try to go to places where people don't go easily, because I just have this intuition that the not so crowded places are the ones where you can generate a lot of ROI. I'm not sure if it's always correct, but that's sort of my business instinct, if you want. It gets me there.
No, the thing is, as long as it's working for you, that's enough, right? So
Yeah,
yeah. And
absolutely.
and with all this know-how of how the human brain works, and also how that could be replicated by using AI, and also building this new form of processor as such, I mean, are you concerned about the artificial intelligence space? Or if you are, then what kind of concerns that you have?
I am very concerned about the current mainstream, but not for. So I'm not fearing the sort of HAL computer or
Humans
how is it?
are taken over.
Yeah, so that's not. I think still human are by far more dangerous than AI. No, what I'm concerned with is at the lowest level, in the context of sort of global warming, ecological impact. People are underestimating how much computing is done today. So if you take all the computing efforts, so from the mobile phone to the server that runs the cloud of different systems, we are talking about more than 4% of the energy turnover globally. Yeah, so this is not a small little fraction, and it's not the coal mining and car steel industry sort of eating up the most energy. So we have reached a point where the amount of energy that we invest in computing sort of becomes a global relevant amount. Scaring is that all industries currently are trying to get ready for their respective green programs that they have and want to implement. The only industry that is not trying to use less energy is the AI industry. Yeah, so that's the only one that has a complete opposite trend to what it actually is, which in the end will mean that AI, if we continue like this, AI will become very expensive. And not building the AI, but running it. If you need to run sort of extensive clusters of GPU accelerators and so on to just do the simple things, yeah, then it will become very expensive, which of course will, as usual, when something is expensive, some of the market will have an advantage, most of the market will have a disadvantage. Yeah? The second thing is that only very few people or very few organizations will be able to provide us with the AI basics. So if you want to work in the language space, for example, you need something that we call a language model to some degree. Yeah? So that's not yet the solution, but that's the basic model that allows you to create a solution with it. But if, like we have seen in with the GPT-3 model that has recently broken our records, just computing it once, yeah, so not computing it to refine it or whatever, takes, I don't know, weeks, many weeks, and it costs you something like $5 million. Yeah, wow. Just to run it once. So who will be the companies or the users who will do this in the future? It will end up being, I don't know, Google, Facebook, Alibaba. They will be the providers for the world of language models. Yeah? So, and as a consequence, 90% of those language models will be either English or Chinese. Yeah. What will the Czech people do in the future? Yeah? How will they operate their Czech AI? Well, that's a problem. Another problem is that having these huge data collection systems that you need in order to feed to your AI algorithms will be dangerous for us as individuals, yeah, because it will be impossible to make a single move somewhere on the internet without being completely sort of tracked and analyzed and categorized and become part of a certain model. Yeah. So, for example, today I shout at my youngest son if he uses my YouTube profile to watch some of his kids' programs, yeah, because he's spoiling my model that I run at YouTube, that I carefully trained to propose me scientific and business content, and suddenly I see a cartoon popping up, and I know, my son has been using my television set with my account in YouTube. So, I mean, that's cute, sort of, but these effects can have a lot of impact. Yeah. Especially if you look at the broader socioeconomic level. You see, for example, how the US is struggling currently with the impacts of social media on politics. Yeah. The point is, it's not so much what people write and post on Facebook. It's all the AI that makes sure that certain people see the postings of other people to precisely provoke interest. And what Facebook didn't realize is provoking interest also provokes the buildup of a wave of whatever. And the problem is the whatever. And it turns out that at least half of the whatever is fake news, because it just rides the same wave as the real news. And with all that AI amplification, you have the posting of several people to have an enormous impact. And so there are companies out there who are aware of this, and they use AI to analyze that phenomenon, which then allows them to cast sort of the right message at the right location at the right time, and with a minimal effort, they can generate millions of people becoming aware of something or believing something, and so on. And that's what Cambridge Analytica and these kind of people, that's the way how they worked on this. So to me, that is the kind of scary thing with AI, is that if we keep doing that naive form of brute force AI, there will be a lot of fallout. Yeah, that's like the first generation of cars. They didn't care on how much carbon dioxide and lead and whatever they pumped in the air. Nobody cared. Yeah? So it's always dangerous to work to hyper industrialize these early technologies. Yeah? So I think that it is a responsibility for governments, for international organizations, and so on, to try and steer also that AI wagon more into the direction of green, efficient computing, because it will then, if you oblige sort of AI to be green, you oblige the people who figure out the algorithms to make those algorithms differently to be more efficient. Now it's nobody's goal to become more efficient in AI. You just buy more NVIDIA cards. Yeah, that's the solution. Yeah, so that's so I think to protect us from the negative impact of this AI trend is definitely a topic. You cannot leave it just to business, because business water always goes downhill. It never goes up. If you want water to go uphill, you have to bring a politician in.
Yeah.
Sort of.
That's a good way to put it together. But one of the concerns that you mentioned about energy consumptions, I actually asked this question to quite a lot of entrepreneurs in the past, because like you said, there are so many devices connected to the internet, every other second, right? So and And then, we have this AI where we need a lot of energy, like you said, in order for a simple operation to take place. But there are also other sectors, for example, the cryptocurrency space, where as well a lot of energy is used, right? Perhaps fundamentally, even there, some form of AI is already being used, right? So if you have to think about the industry itself, then what can be done, as far as going green is concerned. If you think about the solution, perhaps you mentioned efficiency a few times, in this conversation. So I'm kind of curious about what are the possible options for people to really see and maybe apply to their own startups or their companies as such.
Yeah, I mean, it's, I think high efficiency AI is definitely the future. And it's a very uncharted space. That's why I happen to be there, as I said. I
And
love
you are in
empty
Austria.
Yeah. Yeah. So I think that is definitely the area where innovation is needed. And that's where startups should focus, because there are a lot of large organizations already within the traditional AI space, just being one sort of small company trying to do the same thing but better is, yeah, I'm not so optimistic. Yeah, I mean, of course, there can always be the one sort of strike of genius, but as a general advice, I would say try to step in quite fundamentally. Yeah, don't try to build so much on an existing stack. Yeah, I mean, there are so many companies, they just sort of take, they happen to have a certain data set. They take the standard, I don't know, TensorFlow implementation, create a model, and they say, I have a product. Yeah. But I think that this pattern doesn't work anymore. I mean, it worked for a certain time. It was adopted by a certain group of companies, and they are now sort of mid-scale companies by now, or mid-scale startups. But for any new startup, I would say you have to go deeper in the stack and start more fundamentally, because otherwise you will not be able to come out of this vicious circle of using more and more energy. Yeah, and one thing we see with the state-of-the-art solutions is that at the very top of the food chain, they are sort of easy to beat, because they use up also so much money and energy in implementing solutions, as they have to, that if you have a smarter way of doing it, you probably sort of get the deal. Yeah. So compared to the amount of noise, let me call it, about AI, the number of actual implementations in production is super slow, super small, at least in the enterprise world. Yeah, I mean, of course, the Googles and Facebook, they use that as their backbones. But they also have to have thousands of AI engineers in order to do this. But for the normal sort of food or pharma or whatever type of company, you cannot put the effort in AI that Google does, because that's not your core business. Yeah? So if you get the offer for a certain need that you have, and on one hand, you have one big player who asks you 10 million for it, and on the other, you have a startup who focused very much on efficiency and offers it for 100K. It should be clear where to go. Yeah? And I think we nearly went through the phase where the customers still said, yeah, I like your solution better, small company, but for sake of nobody has been fired for buying IBM, I nevertheless buy the IBM. So there was that phase, but I think it's also over by now. So you have more and more, even big companies are making an effort to accommodate those small pilot fish in hope that they will actually solve their problems, because many of the big players have actually failed in produce. I mean, I might restrict all I've said to the natural language part of AI, although I think it might be extensible to some other areas, but that is mostly the way how the natural language AI sort of ecosystem works. Yeah.
And you know, in a different context, like I booked a little bit about the cryptocurrencies, and I was looking at the news the other day, and there is a legalization of one of the currencies, or maybe going more towards a digital currency, especially in the European region. Are you sort of keen on this particular sector, on the digital currency, or being let's say a little bit a centralized economy, or decentralized economy rather? Are you more curious in that sector as well?
Yeah, but not for professional reasons, and I'm far from being a big understander of this. But I think that I think it is a good thing because it, as you say, democratizes this influence on money, if you want. To me, money is fundamentally energy. At some point, and so
very soon.
So having cryptocurrency is a link for the first time from information to money and not from energy to money. I mean, it's true currently to mine cryptocurrency, you still need energy. But just imagine if you would mine energy with solar panels, then if you would mine crypto coins with solar energy, then you would generate money without any carbon footprint, or nearly without any carbon footprint. And that, I think, is again a very fundamental thing, that suddenly it's not just energy that links to money, but it's also information directly, namely. And I think that this will introduce a number of interesting socio-economical developments to come. So we are in very early days. I think that some of the conservative parts of the financial world are still trying to sort of isolate and compartmentalize Bitcoins to some degree. But as it is very often with sort of generative new technologies, there will be the point where they will have no means by which they can limit it anymore. That's the same thing as with the internet. I mean, when I remember the first internet I saw was at the university. The university network basically allowed me to find FTP servers in Chicago. Nowadays, you cannot even cut the internet if you are under hacking attack. So you have to keep online all the time. That's very unfortunate. So there is no more choice in this, and you cannot just simply get rid of something or someone by cutting them off the net. That doesn't work. So I think that crypto coins at some point will get sort of into the game very massively. And I think it's again it will be the role of the politicians to ensure that becomes sort of socially valuable and does not become the way how criminals can do money laundering. So as long as it's sort of put to a side. It's perfect for these kind of things like money laundering and so on.
Yeah.
But whenever it gets really adopted and becomes part of the official sort of legal context, I mean, the same thing happened when sort of stock exchanges started, basically. Yeah? So the very first stock exchanges, I'm pretty sure that there was a lot of criminal activity there until it started to become regulated and managed openly by society. Yeah. Yeah. So I think it's looking forward. It's quite challenging times for politicians, because politics in a world where every bit of information can be everywhere in a second, very soon you will find out that just saying stuff that has no meaning isn't enough anymore for doing politics. So it will be challenging. But on the other hand, I mean, in Europe, for example, it's interesting to see that more and more small, young political movements start to participate the political discourse. Yeah, even in conservative countries like Austria, we have as one partner of the government is the Green Party. Yeah, so 10 years ago that was not yet thinkable. Yeah? So I do think that what we see will be a lot of change in political culture, also in the US. I mean, what you currently go through will definitely have a long-term impact and hopefully renew the old structures that were there. So yeah, I think policies will be key on if we look into a bright or a dark future. I mean, policies are always important, but I think currently they are of particular importance to be well chosen.
Yeah, I also feel like it's a transformative, the next decade would be more of a transformative decade, because we've seen internet, we've seen a lot of things that has happened, and we've also seen now the digital currencies as such, which perhaps even 5 years ago, perhaps people would laugh at you, like when people are talking about digital currency, right? But it has accelerated so fast that now the same people like who were laughing at you, now they are curious about, like, oh, this is actually something serious now, right? So so it's a very transformative phase, from my experience, I would say.
Yeah, and we have just to be careful that it's not just the business world sort of propelling this, but that there is also some sort of civilizatory input. Because one thing I think we have definitely learned over the last 100 years, if you make industrial and economic development a pure business topic, that will sort of end up in being good for a small number of people and bad for a big number of people. So I think that sort of the public policy making and sort of a free business world, they have to come together, and they have to realize that there is no part of the system that can be successful without the others. Yeah, so I find it interesting, for example, a very traditional discussion here in Austria, for example, but I think it's quite similar everywhere, is that there is this one party that stands for the business people and the other party that stands for the working people, and they have to fight in who's getting the next benefit. Is it the working people or is it the business people? And I keep saying I don't understand why they are doing this effort, because I'm pretty sure that you could come up with a reasonable enough model of the economy, let's say, in Austria, and you can probably find where is the sweet spot to put the wages, and where is the sweet spot for putting the taxes that need to be paid, so that all of the economy sort of generates the most output. Yeah. And then we might discuss on implementation details. Okay, that might be politics, but to try and make the argumentation play sort of replace an actual model that tries to optimize that question, that is something that looks just antiquated to me. Yeah. Because of course, if you ask several scientists, they will come up with slightly different numbers, but I think they will still all be more similar to each other than the positions of the parties when they discuss about these things. Yeah. Yeah.
Yeah, well, it's a sad story that, but then, but what I'm surprised is, like, all these parties or all politicians, they're also a part of our own culture, right? They are people that brought up within the same culture, and then as soon as they are in that position, perhaps the beauty of the chair itself is going to, I don't know, make them make them a different person or something. I don't know how that works myself, but somehow that's a sad story. Because from my understanding, they were a part of the society.
Yeah. Yeah. They are supposed to represent society, actually, yeah? Or at least part of the society. Yeah.
Yeah. Yeah.
But again, as I think, and that's something that the COVID pandemic also showed very nicely, is that the fact of someone being politician, it is not necessarily correlating with the knowledge or the scientific relevance of what they say. Yeah.
Yeah. Yeah.
And there are just certain areas where you should let specialists figure out what to do. Yeah. I mean, to see a politician talk to me about COVID, it's just crazy. I would prefer to have a virologist or an epidemiologist talk to me about this. I mean, what I would like to hear from the politician is what kind of operational measures is he taking for whatever. Yeah. But to tell me about COVID, thanks a lot. Yeah. And then even worse, if he says stupid things, then it's even worse. Yeah. Because then I won't take him serious for all the other topics either. Yeah.
Yeah.
So I think that there has to be more involvement of sort of know-how and science into certain levels of decision making. Yeah. And that is a renewal process that will have to happen in the way how we do politics. And as so often, the US is sort of showing us in very dramatic ways this process. Yeah, I think once again, the US seemed to be ahead of all the others currently, because you had a very vivid sort of example of that situation by having a mix of political problems together with COVID problems and so on. And there needs to be a solution now. I mean, whatever happens, something has to happen and will happen. And other areas of the world are not yet there. Yeah. So unfortunately. So
that's an interesting way to look at the present times. You mentioned about COVID, and I want to maybe deep dive into slightly into your entrepreneurial side, where you are also facing the similar challenges like most of the other entrepreneurs. And pre-COVID, perhaps you were working close in a close proximity with your colleagues or your employees. And how are you making sure that the same level of energy is there? Because it must be very challenging for people working from home all day.
Yeah, it's even a paradox to some degree, because on one hand you have the impression it's a bit harder to get things done. On the other hand, I mean, now we have, let's say, nearly a year of COVID behind us. I don't hesitate if I contact one of my fellow employees at 7 at night or so. Yeah, I would never have expected him to see him maybe on in the office, but now I just ping him because I have this question to ask, and I, of course, also respond at 10 at night to requests and stuff like that.
Mm-hmm.
So interestingly, people seem to work more in a certain way, while it is a bit harder to sort of work together. And on the other side, which I face, of course, often, is the communication with customers is actually problematic, of course. Yeah, because talking with customers is a lot about sort of seeing the other in the eye and sort of having all this tiny instinctive sort of information on how to better choose your words or whatever. And all of that is just made, it's just super hard to sell by Zoom. Yeah. The advertisement might say otherwise, but if you try to sell in the enterprise space, especially over Zoom, it's quite hard. Yeah. And I see also that all the strategic aspects of trying to approach someone for initiating a partnership or whatever, you don't do that easily by calling on Zoom. Yeah, you do this by writing an email to someone saying, "Yeah, I'm in town next week. Do you have time for going on a coffee?" And that's how you sort of get things going.
Yeah.
But how do you do this remotely? You have just simply to get a meeting, an appointment. Yeah. So that's what I find a bit challenging. And what also was basically the problem business-wise, because when I had the feeling, okay, I think in 3 weeks the guy signs a contract, during COVID times might happen to become 3 months. Yeah, just because everything was just a bit unsmooth, sort of. And we are lucky in the sense that we are in a domain that's quite needed. Yeah, so there is, even during COVID, people kept being, if not even more, kept being interested in sort of automating certain business processes and stuff. So in fact, we are, how would I say, like the people who sell shovels during the gold rush. You know, that's the kind of position you can come in. But I see for many other industries, it's just all, yeah, very, very bad. And the point is, if the majority of the businesses have issues, the economy has issues, and if the economy has issues, everybody has an issue. Yeah? And that is a bit of the problematic situation we're in.
Yeah, I think for some of the business, especially in the tech space, I think COVID has become more of a catalyst, you know, or accelerated companies' adoption towards AI, or you know, any other forms of let's say tools or processes. And quite rightly, you're in a very niche space. What are the things that, you know, going forward for your company is going to be interesting, you know, to solve?
You mean technically or
Technically, or
business?
yeah, I mean technically, or there might be something that you're, these are some of the areas that we want to tackle, you know, which we have not really tackled. And maybe going forward, we want to look into those areas and try to solve those problems that otherwise it is still in your backlog somewhere hiding.
Yeah, I mean, our goal in the end is to make AI, or let's be more precise, language AI, a business commodity. That's actually what we hope to do. So that in the same way as you get yourself a content management system, if you have content to manage, you get yourself an AI system if you have smart decisions to be made or whatever. Yeah, and that's, I think, where the whole sort of development will go. And we have just to realize that we need to find a partner, basically, who has already a big enough footprint in the business IT domain, and who is also sort of sharing with us the view of where the future will be. Which is a bit of a contradiction, because the typically large sort of companies in the IT space, they tend to be super conservative. Yeah, they might not say that from themselves, but they are. Yeah, yeah. They have their cash cow, and they want just to continue doing their cash cow. This is, I think, the main powering of conservatism. But yeah, that's basically the goal, is to find a sufficiently large partner, because if we sort of start to compete, which we did not sort of by design until now, but if we start to compete against bigger players, we need to be bigger ourselves. On the other hand, if we just grow the company, then we also grow conservatism. So one of our main attributes, being innovative, will diminish by the size we are getting to. So I definitely would want to avoid that kind of setup. So we either need to find a strong partner, or what I would like even more is a concept of business swarming, I would call it, to find a motive or structure, if you want, that allows a large number of small business entities to sort of work together in a field. Yeah, so these are the ideas that I see for our future. Yeah.
All right, Francisco, I think I've already eaten up all your time. You know, I tend to go off topic all the time, and that's I think
I love that.
I like. Thank you. I think that's my specialty or something. I don't know, but it was thoroughly enjoyable conversation with you. I really wanted to understand how you are operating on this difficult time as well. So I get to learn a lot, and thank you for allocating this time for me in this session.
Thank you for having me.